Qualitative data is any non-numerical information collected during an experiment. And this effectively means any observations you record that are not measurements. Now, instead of describing a beaker or the colour of a solution, we want to make sure that these qualitative observations are useful for considering sources of error in our methodology. And if you're writing a lab report for a specific investigation, it might be useful to present these observations in a table with a label and perhaps even number the observations so that you can refer back to them, something like this. Let's have a look at a couple of common investigations in IB chemistry and consider which qualitative data might be useful. The first example we'll look at is calculating the empirical formula of magnesium oxide. In order to do this, we weigh a piece of magnesium, then react it with oxygen using a Bunsen burner, and then weigh the magnesium oxide produced afterwards. So let's take a magnesium strip, which, given it's a metal, I would expect to be a silvery, shiny colour. But in reality, when we get a piece of magnesium in the lab, it often has a dull appearance, as you can see in my little sketch diagram there. So a qualitative observation I might record is that the magnesium strip appears a dull grey colour instead of the shiny silver colour I might expect. And why is this a relevant observation to make? Well, if it's not the expected appearance, this might indicate a lack of purity in my magnesium. And this is definitely going to be a potential source of error in my methodology because it means that the recorded mass of my piece of magnesium is actually going to be greater than it should be because there are impurities. If you're writing an evaluation section for this lab, you'd have to go a step further and consider what impurities there might be. For example, magnesium when exposed to oxygen in the air actually will form a layer of magnesium oxide on the outside before I've even started my official reaction. The observation itself would go in my qualitative data section, and then the consideration of this as a source of error in my experiment would end up in the evaluation section of my lab report. The next step in this practical would be to react my magnesium strip with oxygen in the air using a crucible and a Bunsen burner, something like this. Of course, the crucible is not just floating in the air, you would have some other equipment holding it in place. So as the piece of magnesium reacts with oxygen in the air, we occasionally need to lift the lid to allow more oxygen in. And when you do that, you might notice a white smoke emerging from the gap. And this might be an important qualitative observation to record. And why might this be important? Well, we know that magnesium oxide is a white powder, so this white smoke might well be magnesium oxide particles leaving the crucible, and this is then going to affect the mass of magnesium oxide remaining in the crucible after I've finished heating. Specifically, the mass of magnesium oxide that I record is going to be lower than expected because some of it seems to be escaping. And in an evaluation section, you'd be expected to explain how that might impact the final empirical formula that you calculate. Again, that first observation goes in my qualitative data section, and the explanation for how this indicates a source of error and the knock-on effects on your final calculations will go in the evaluation section. Of course, in an evaluation section, once I've identified sources of error in my methodology, we try to suggest realistic improvements that would minimize those sources of error or perhaps even eliminate them. Let's take a look at a second common practical and a possible qualitative observation that we might make. So for the second example, let's consider an acid-base titration using methyl orange indicator. In this example, let's take the basic solution and use it to fill a burette. And then underneath the burette, let's put a conical flask containing an acidic solution with a few drops of methyl orange indicator, which would turn red in acidic conditions. In a titration, we use an indicator to determine the end point of reaction, and in this case the colour change we would expect to see is from red in acidic conditions to yellow in basic conditions. Now that sounds easy enough, but as I add my basic solution to the acidic solution and begin to neutralise it, the colour change we're actually looking for in between red and yellow is an orange colour. Now this might be a useful qualitative observation, because identifying exactly the same orange colour in each trial of your experiment is going to be difficult because we are humans and our judgment of colour is certainly not perfect. And this is likely to impact the accuracy of the volume measurements that we are making, which ultimately is going to affect the accuracy of the concentration of the unknown solution that we're trying to calculate in a titration. Again, the observation itself is the qualitative data, and the consideration of this as an issue in the methodology would be considered in the evaluation. Let's now summarise the key points from this video. Qualitative data is non-numerical information, and more specifically we're looking for observations that are related to sources of error in your methodology. As good practice, you'll want to find at least one in every experiment you do, and we consider the implications of these observations in the evaluation section of a lab report. Hopefully this video was of some help.